Hi, my name is Johnny Hancock, Product Manager for Keysight's Infinivision oscilloscopes. The oscilloscope is the core test instrument that you'll probably be using most to test the circuits in your lab. So it's important that you learn how to use it. Unfortunately, the oscilloscope is also the one instrument that engineering students tend to struggle with the most. That's why we created this video series. But before we jump into learning about the fundamentals of using an oscilloscope, this first lesson is going to be an overview of the 4 primary instruments that you will find at each test station in your circuits lab, which includes a digital multimeter, a DC power supply, a function generator, and an oscilloscope. Let's get started. DC power supplies are used to provide DC power to circuits. Almost all electronics run on DC voltage, even if it originates out of your wall socket as AC voltage. This particular DC power supply is a triple output isolated power supply. As you can see here, I've got channel 2 output of this power supply set to 10 volts and is powering up a simple resistive divider circuit. When the DC power supply is connected to a circuit, besides showing the fixed DC output level, it also shows you the amount of current that is being drawn as well as the amount of power that is being delivered. A digital multimeter, or DMM, can make precision voltage and current measurements on DC and lower frequency AC signals. It can also measure the resistance of your components, temperature, plus a few other things. This is a handheld DMM, which is what I mostly use in my lab. But engineering professors and lab coordinators tell us that these things tend to walk away. Let's make a few measurements with the one that tends to stay put. With my DC power supply set to 10 volts and connected to this simple resistive divider circuit, based on Kirchhoff's voltage law, there should be about 9 volts dropped across R1 and about 1 volt dropped across R2, which has a value of 100 ohms. Let's verify that with this DMM. So let's measure the voltage across R1. We can see that it measures 9.01 volts. That's pretty close to what I expected. And across R2, it says 0.988, which is about 1 volt. That's pretty much what I expected. But what if we'd measured 0 volts across R2, which might indicate a short? Or what if it measured 10 volts, the input voltage across the whole network? That might indicate an open, maybe something's burned out. So the next step might be to measure the resistance of my components. So first of all, I'm going to change over to ohms on the DMM. And next thing, very important, disconnect power from the circuit. And now let's measure the resistance of both components. So R1 measures 0.909 k ohms, which is about 900 ohms, and R2 measures 99.9 ohms, pretty close to 100 ohms. So everything looks good here. Function generators, sometimes called waveform generators or arbitrary waveform generators, produce dynamic inputs for your circuit designs. You'll probably be using these a lot for your lab experiments. These instruments can generate repetitive sine waves, square waves, and triangular waves, as well as other wave shapes of various amplitudes and frequencies. We'll be using this function generator a lot during this video series. I'm going to now disconnect the DC power supply from my resistive divider circuit and plug in the function generator, which I've already set to generate a 10 volt peak-to-peak signal, 20 kilohertz sine wave. And now for the star of the show, the oscilloscope. Most engineers simply call it a scope. Some call it a DSO, which stands for Digital Storage Oscilloscope. Our friends down under in Australia often call it a crow, but it's not in reference to the bird. It's an acronym for Cathode Ray Oscilloscope, CRO. But don't tell the Aussies that today's oscilloscopes don't have cathode ray tubes. Now, you might call these things your worst nightmare, but let's hope not, because this is the core instrument that you'll be using to test your assigned lab experiments. An oscilloscope's primary purpose is to graphically display time variant waveforms. This oscilloscope also has a built-in one-channel function generator, which is probably good enough for most of your experiments, but since I have a better function generator, I'll be using this function generator for most of my demonstrations in this video series. With my oscilloscope probes connected to the input and output of this circuit, now we see two waveforms displayed on the oscilloscope in a voltage versus time format. We'll be talking about probing in lesson 3. Voltage is displayed on the vertical axis, while time is displayed on the horizontal axis. But oscilloscopes can also measure current versus time, voltage versus frequency, voltage versus voltage, and even gain versus voltage, which is a Bode plot. We'll get into some of these more advanced types of measurements later during this video series. Now notice, as I increase the voltage from the function generator, get bigger waveforms. As I decrease the voltage, smaller waveforms. And the same thing, if I change the frequency, if I increase the frequency, we see more cycles on screen. As I decrease the frequency, we see less cycles on screen. When I was in engineering college over 40 years ago at the University of South Florida, about the only thing the old analog oscilloscopes that I was using could do was display waveforms. But today's digital scopes can do a lot more than just display waveforms, as you'll see in this video series. These scopes can have lots of buttons and knobs, and at first it can be very intimidating to some engineering students. But it's important that you learn how to use the various controls so that you can drive the oscilloscope, and I'm going to help you do that. If you can master how to use the oscilloscope, it's going to help you master your various engineering circuits classes. Don't let this thing intimidate you. It can be your best friend if you get to know it. Well, that's it for our first lesson on getting acquainted with the essential tools in your undergraduate teaching lab. In lesson 2, we will learn how to properly scale waveforms on your oscilloscope. And before I let you go, note that Keysight has lots of technical resources on oscilloscopes for engineering students that you can download at the URL listed on your screen. See you in lesson 2. Go USF Bulls!